Good morning, everyone. My name is Mariusz Barczak. I'm Cloud Storage Software Architect at Intel, and today I'm going to present you the project Cloud Storage Acceleration Layer, which enables storage performance and capacity scaling for big data workloads and environments. But first, let me show you a couple of notices, and then we'll be able to get started. Currently, we observe a trend of data growth. We collect and compute more and more data. We are going to double capacity of our data in a couple of years. This leads to compute performance growth as well. CPUs delivers more cores which are capable to process more data. However, current storage architecture based on HDDs is not able to meet the requirement of performance and capacity scaling. It's inefficient due to low performance of small reads and writes and generally poor performance of random workloads. As well, using this type of storage in multi-tenancy environment is impossible. It's a known problem for HDDs. This was reported by our partner Alibaba in EBS D2C storage system. Fortunately, new storage media such as Intel Optane SSD and QLC 3D NAND have emerged to help us break through storage bottlenecks and store massive amount of data in much more efficient way. However, with multi-cell NAND technology, we experience a new challenge. The performance and endurance decrease with greater capacity for such drives. Existing storage dynamics that assume a homogeneous and simple media structure cannot realize the full value of these media types. To unlock the value of modern media and remove storage bottlenecks in your system, a more intelligent data-driven approach is required to place data. This allows you to build high-density store architecture, which provides consistent performance at low cost. I think that describing problem is a commonplace for other cloud service providers. Big data workloads require high capacity, but this could result in a performance degradation. I am a member of a team that, in collaboration with our partner Alibaba, creating cloud storage acceleration layer. Thanks to that, Alibaba has already started the new storage service EBS D3C instance. It is capable to achieve scaling capacity and performance. It is consistent in terms of bandwidth per terabyte and in terms of growing number of CPU. We can provide constant performance of bandwidth per virtual CPU. Using Intel Xeon processor, Intel Optane SSD and high-capacity QLC NAND device, we can remove storage bottlenecks and analyze more data in less time. And finally, because of higher density, we can save rack capacity and space. Okay, a few words about the solution. Cloud Storage Acceleration Layer is an open source project developed in SPDK environments. To build it, we decide to use shared nothing architecture to deliver scaling performance together with growing number of CPU cores. The software provides flexible scaling of performance and capacity to the end user needs. For example, it is possible to split a physical 16 terabyte devices to logical volumes of 2 terabyte, 4 or 8 terabyte size. To improve performance, Intel Optane SSD drive is used as an ultra-fast cache device. Also, it helps to extend the solution endurance, while at the same time we reduce cost. This deployment based on Xeon native storage and deliver non-compromised I/O performance. Now let me present a couple of results. Alibaba Cloud D3C instance and Cloud Storage Acceleration Layer provides 35 times better performance for 4K random write workloads comparing to QLC drives. Workloads with Xeon distribution can be executed 8 times faster. And all this within one server, which is able to provide 128 terabyte capacity. Okay, now let's focus on architecture details. According to the problem, HDDs and non-extreme high density drive, their performance on latency and endurance are not enough. HDD has low bandwidth. On the other hand, NAND SSDs performance decrease with capacity growth. As an initial solution, you might be thinking to introduce a regular cache. However, it still will be limited by QLC backend performance. We had to develop a dedicated caching and buffering solution. Cloud Storage Acceleration Layer provides intelligent data placement mechanism and friendly storage management, which can serialize writes to NAND tier. CSAL delivers flash translation layer, which is optimized for the pair of Intel Optane SSD and QLC capacity storage. In addition to data path, we know manageability is very important, so we provided improvement around time to service. Time needed for recovery from power failure or process crash was shortened a lot. For example, if storage service process crashes, the CSAL can be rerun within less than half of a second. Okay, let's move to the second point. We use Optane SSD not only for keeping data, but we know because of ultra-low I/O latency, we decided to utilize Optane SSD as a metadata tier. CSAL asynchronously accesses the L2P table. In future, it is possible to run L2P table using Intel Optane persistent memory. It will simplify design and improve manageability a lot. Now we can focus on point number 3. Next very important component of this software is persistent write buffer. This has very important function in our system. First, it intercepts workload locality. Second, it takes over small writes from the NAND device. Third, we stage user writes directly to the device and complete the I/O. We don't need any DRAM buffer and user data are power failure safe. In future, we plan to develop the write buffer based on Intel persistent memory and data streaming accelerating engine. Okay, let's move to 4 and 5. The next part is our storage analytics. It hints data and it will help to deliver better data placement decision. We know storage analytics together with ZNS drives are required to release tenant isolation with high quality of service for each tenant. And finally, the point number 6. This architecture can be easily extended to support data redundancy. It can work together with RAIDs. RAID 5 and 6 can work on QLC devices, and because CSAL writes only using full stripes to the backend devices, we don't have penalty because of in-place updates, or we don't have RAID write hole closure problem, like in case of standard RAIDs. Optane's data will be protected by RAID level 1. This is the whole picture of our solution. Let me conclude this presentation. Intel and Ali innovation. So cloud storage acceleration layer and Alibaba Cloud D3C instance powered by Intel Xeon Scalable Processor, Intel Optane SSD, QLC SSD, uses intelligent and data-driven approach for data placement. All these can deliver consistent performance growth in domain of capacity and increasing number of CPU cores. This is achievable at high capacity in one server and it decreases cost. The big data workloads may compute more data in shortened time. Okay, so here I'm presenting a couple of references that you can take a look. At the moment, CSAL patch is ready and we push it to SPDK for review. We are working on it. And I think next steps will be support for RAID, ZNS, TLC, PLC. And we plan as well to share with you NVMe over Fabric solution reference, results and design. Thank you for this presentation, for your time. Please take a moment to rate this session. We'll be glad to get your feedback and tell us how cloud storage acceleration layer can help in your environment to speed up big data workload as well other workloads. Take care. Bye.